Hi everyone, welcome to this video. We are going to see how we can compute different reliability estimates in this video. To motivate this video, we have this example of a measure of cognitive and affective empathy. So here we have items of cognitive empathy, here items of affective empathy, and none of these items are reversed. And we also have, even though we cannot see it that well here, we also have a retest for the cognitive total score and a retest for affective empathy, which will help us know about test-retest reliability. To motivate this video, I use here these little questions that we're going to follow. Okay, so the first thing that we are asked to do is compute Cronbach's alpha for the cognitive and affective empathy subscales for each of these two subscales. So in SPSS we're going to go into Analyze, Scale, Reliability Analysis, right? And on there I'm going to select first my cognitive empathy items. I'm going to put them here on the right. I'm selecting alpha, it's already pre-selected by default, alpha. And here in statistics, I will also click here on scale if item deleted, because I am asked later on, to signal any item that lowers Cronbach's alpha for both subscales and thus might be candidate for removal. So to find that, I'm going to compute Cronbach's alpha if I deleted an item. So I'm going to select here this scale if item deleted. Right, let's click on continue and OK. So I can directly answer the first question: what is Cronbach's alpha for cognitive for the cognitive empathy scale? So that's 0.793. And I see here, for question 2, that I have an item that lowers the alpha. In other terms, if I removed this item, cognitive 4, I would actually have a better alpha, right? So that's a potentially good ID to remove that item, right? Even though we are not asked here to make that decision, if we had to remove one, that would be a good idea to remove this one. Let's do the same thing for affective empathy. So I can recall here reliability analysis. Let me reset that. I'm going to select the affective empathy items. So of course I'm selecting only the items and not the total scores. And in statistics, I'm going to check scale if item deleted like I just did. Still alpha, right? The model that we're choosing is the default. Let's click on OK. Right, and I've essentially here again a good alpha, but I see that if I removed item 5 here for the affective empathy scale, I would have actually a better alpha. So in other terms, the 5th affective empathy item is also a good candidate for removal, even though we're not asked to make that decision. Right, so I've done question 1 and question 2, right? Cronbach's alpha is here and there. And the items that we could signal as lowering the alpha would be cognitive 4 and affective 5. Third question, compute the predicted Cronbach's alpha if we had 15 items instead of 5 in the cognitive empathy subscale. And we have a little hint to use Spearman-Brown's formula. Right, so here on Excel I have put this formula, Spearman-Brown's formula, and we see that it's a formula for predicted reliability estimates based on an actual estimate and based also on the change in test length. And the change in test length is represented by this n. So what do we need here in this formula? Right, so the only two ingredients that we need is n. So n is the number of replications of the original test length. So here the original test length is 5 and we want 15 items total. Right, so in other terms the number of replications is 3. Right? Another way we can compute that is by computing. Right, sorry, let me write the full thing. Let me zoom in. Alright, doesn't work. Okay, right. So here, the original test length is 5, right? 5 items. And for the prediction test length, 15 items, right? And so the n is simply what we predict over what we have, right? So that's the change factor, so to speak, right? So we need to multiply test length by 3, essentially. And we also need here the reliability that we have for this original test length, right? So the original reliability, and so we here will use Cronbach's alpha, and we are being asked to do that. This question is about the cognitive empathy subscale. So in other terms, I will use here this Cronbach's alpha of 0.793 here. Right, I have everything now, so I can directly use this formula to predict my reliability. So I have this, so I have a numerator and a denominator, right? So equal something on the numerator divided by something in the denominator. And so what is in the numerator? That's n times the original reliability. What do I have as the denominator? It's 1 plus, between parentheses, n minus 1. So n is right here, n minus 1. And outside of the parentheses, times the original reliability, which is right here. All right, and we do have everything now. Let's click on enter. Okay, and so we have our predicted reliability about 0.92, which makes sense because here the test length is bigger than the original test length. Right, so it makes sense that we have an increased reliability, predicted reliability. Okay, going back to my questions now. We need to compute test-retest reliability for the cognitive and affective empathy subscale. So test-retest reliability is one of the forms of reliability. And here in that case, apart from Cronbach's alpha, that is actually the only one that I can compute. That is because I have, actually have these variables here of retests. The only problem here is that I don't have the original test scores, so I need to compute them basically. And so to compute them, I just need to sum here the cognitive empathy items on one side, and also I will need to sum these up. So how do I do that? I could use Excel to do that, but here I will use SPSS. So I'll click on transform, compute variable. I'm going to create a variable that is going to be called cog. Right, simple as that. I can also give it a label if I click there, right? So I will not do it, but of course I can say that it's cognitive empathy, right? Here I have very few variables, so that's okay if I don't have labels to recognize them. So I'll just use cog for this sum score. And the numeric expression I'm going to use is actually the sum formula, which, by the way, we can find here. So if you click on all, and then you can scroll down, and you will be able to find the sum formula right here. If I double click, I have it here. But I can, of course, also write it myself. Right, and so the arguments is basically whatever we want to sum up. So I'm opening the parentheses, closing the parentheses, and in between I'm going to put here all of my items. So I'll double click on it. Cognitive 1, comma, cognitive 2, comma, cognitive 3, comma, cognitive 4, comma, and cognitive 5. And so I'm going here to create this new variable which will be the sum of these 5, which is exactly what I want. Let's click on OK. Right? So if I have a look here on my data set, which is right here, my data set, I have now a new, or at least I should have, a new variable computed. Couldn't see it. So I have a new variable computed called cog, which has the original test cognitive empathy scores. I'm going to do the same for affective empathy. So transform, compute variable. I'm going to reset. Okay, so the second one will be called aff, right? And so it's going to be the sum of 5 items. So affective 1, effective 2, effective 3, effective 4, and effective 5. Right, I can also, by the way, type them, of course. And that's it. Just click on OK, and now I have my new score, effective empathy. And so now I can compute my test-retest reliability. So I can go on Analyze, Correlate, Bivariate, and I will compute the correlation coefficient between the test and the retest. Bivariate. Right, well, it's a big menu. Right, so I will here choose cognitive empathy and see if it's correlated with retest cognitive empathy. Right, it's going to SPSS is going to compute the correlation between the two. I don't need to change anything here. I use Pearson correlation coefficients, two-tailed significance. Let's click on OK. And so I find a test-retest correlation of 0.93, which is very good. So that answers my question here for cognitive empathy. Let's do the same for affective empathy. So analyze, correlate, bivariate. And here I'll remove these two variables, but I will here use affective empathy and retest of affective empathy, and here I'm not changing anything. Let's click on OK. And here I have also a very good test-retest reliability for the affective subscale. Now compare the average total scores at the test and the retest. So now more than looking at the correlations, we want to know if at the retest individuals had higher scores, for example, or lower scores than at the test. To see if something changed on average between the two series of measures, right, at the test and retest. So to check that, here we actually have a repeated measures design, right, a test and a retest. And so we're going to use a paired samples t-test, also called a paired t-test. Let's click on Analyze, Compare Means, Paired Sample t-test. Okay, and here I'm asked to choose my paired comparisons. So I'm going to do them one by one, right, for affective and cognitive, but know that you can actually do the two at the same time in the same dialog box. So cognitive is going to be my first measure, and retest cognitive is going to be my second measure, right? So cognitive, retest cognitive here. That's it. I don't need to change anything, right? Sorry, I had to click here. I don't need to change anything, can just click on OK. Okay, let me see the results. So here we have our two means, right, which are very, very similar, right, our two mean scores at the test and retest, very similar. And here, if I have a look at the paired samples t-test, what I see when I have a look at the t-test actually is that the p-value of this mean difference is very high, and notably it's higher than 0.05. In other terms, the mean difference is non-significant, right? So we can say that we don't have a significant difference between the test and the retest scores for the cognitive empathy measure. Okay, moving on to the affective empathy measure. So I'm recalling the same dialog box, paired sample t-test. I'm going to reset that. And so here my first variable will be affective empathy, and my retest affective will be my second variable. Okay, and that's it. So affective, retest affective. Okay. Okay, so here, same thing. I see very similar means, right? And here, I see that the mean difference is non-significant as well because I have a p-value higher than 0.05. So in other terms, I can say that there is no significant mean difference between the test and retest scores for affective empathy. Right, and that concludes this video on test-retest reliability and internal consistency.